guys, welcome to our channel Digitalized Learning. Myself Megha. Today I'll be taking part 2 of chemical reactions and equations. In the previous video we had done part 1 of the same chapter, wherein we had covered various topics like what are chemical reactions and equations, what is an unbalanced equation, what is a balanced equation, and the steps to balance a chemical equation. Now here in this part 2 of the chemical reactions and equations, we'll be covering the topics like types of chemical reactions and also various effects of oxidation reactions in our daily lives, that will include corrosion and rancidity. So let's move ahead with the chapter. So now the first type of chemical reaction is a combination reaction. Now, as the name suggests, what's a combination reaction? It is basically a combination of two or more reactants giving rise to a single product. Okay. So now let us look at the first example given here, which is calcium oxide reacts vigorously with water to produce slaked lime, that is calcium hydroxide, releasing a large amount of heat. So here's an example of combination reaction wherein we can see that calcium oxide is reacting with water to give calcium hydroxide and is also releasing heat. Now here what we can observe is there are two reactants, that is calcium oxide and water, getting combined to give a single product, that is calcium hydroxide. So we can say that a combination reaction is a reaction wherein two or more reactants combine with each other to form a single product. Now let us look on to various other examples of combination reaction, which is burning of a coal, that is C plus O2 giving rise to CO2. Two reactants combining to give a single product. Again, the next one wherein we can see combination of 2H2 plus O2 giving rise to 2H2O. Again, here also wherein there is formation of water from H2 and O2, there are two reactants combining with each other giving rise to a single product. So this is what is a combination reaction, wherein there is combination of two or more reactants giving rise to a single product. Now in the above example of combination reaction of calcium oxide and water, we are seeing that along with calcium hydroxide, that there is also heat that has been released. So whenever there is heat released in the reaction mixture, it makes the reaction mixture warm, and this is an exothermic reaction. Exothermic reaction is a reaction wherein heat is released. Okay, so some of the examples here are some of the examples listed wherein we can see the exothermic reaction taking place. The first one is burning of a natural gas. Here the reaction is CH4 plus 2O2 giving rise to CO2 and 2H2O. And another very much important example of an exothermic process is the process of respiration. Now what happens is that our body needs energy to perform its functions. Now where does this energy comes from? Now whenever we eat our food, like suppose we consider some of the food items like rice, potatoes and breads, etc., which consist of carbohydrates. Now our system will break down these carbohydrates into simpler substances to give it will give rise to a product called glucose. Now this glucose, which is produced as a result of breaking the carbohydrates that we consume through our food, combines with the oxygen which is present in the cells of our body, and it will give rise to energy. This energy will be utilized by our body to perform its various functions, and the special name which is given to this kind of a reaction is respiration. And if we see onto the chemical equation of respiration, it is C6H12O6 plus 6O2 giving rise to 6CO2 plus 6H2O plus energy. Now another example of exothermic reaction is decomposition of vegetable matter into compost. So this is also an example of exothermic reaction. So now here we are done with the first type of a chemical reaction, that is combination reaction. Now let us move ahead with the second type of chemical reaction, that is decomposition reaction. Now again, as the name suggests, decomposition, that is here what happens is that the reactant gets converted into simpler products. Okay, there's a single reactant, it will get broken down and it will give rise to simpler products. Now let us consider an example. 2FeSO4 giving rise to Fe2O3 plus SO2 plus SO3. Now what is the observation in this above chemical equation is that the ferrous sulfate crystals, the FeSO4 which is there, it will lose the water content in it and the crystal's color will get changed, and further it will get decomposed into three products. Okay, the first would be Fe2O3, which will be in the solid form. The second will be SO2, which will be in the gaseous form, and the third one is SO3, which will again be in the gaseous form. So here we can see the decomposition of FeSO4 into Fe2O3 plus SO2 plus SO3 taking place. And now the next reaction which has been mentioned there, that is the decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating. This equation is an industrially important equation. Now let us see why. What happens here is that the posed to form calcium oxide and carbon dioxide. Now here the calcium oxide is also known as quicklime. Now this calcium oxide has many uses. One of its important use is in the manufacturing of cement. Okay, and also whenever a decomposition reaction is carried out by heating, it will be known as a thermal decomposition reaction. Now let us move ahead with the third type of chemical reaction, that is displacement reaction. Now again, as the name suggests, displacement reaction, that is displacement. There is moving or exchange of places that is occurring in the reaction. Now let us consider an example. Fe plus CuSO4 getting converted into FeSO4 plus Cu. Now what is happening is that in this reaction, iron has displaced or removed another element, copper, from the copper sulfate solution. This reaction is known as a displacement reaction. Now what has iron done? Done here is that it has exchanged the place with Cu, and it has now the product has become FeSO4 and the Cu has been made into another product, and Fe has taken the place of Cu, and this is what is a displacement reaction, wherein the exchange of places takes place. Now there are more examples, wherein the first one is Zn plus CuSO4 getting converted into ZnSO4 plus Cu, Pb plus CuCl2 getting converted into PbCl2 plus Cu. Now what is happening is that zinc and lead are able to replace copper in CuSO4 and CuCl2. The reason being that zinc and lead are more reactive elements as compared to that of copper, and hence they have that power to replace that Cu from both the CuSO4 and CuCl2, and hence they displace copper from its compound. Now the next one is a double displacement reaction. Now what is actually a double displacement reaction? It is a type of chemical reaction in which the reactant ions exchange places to form new products. So here there is exchange of places between the ions present in the reactants, and whenever there is a double displacement reaction taking place, there is usually formation of precipitate. Now what is a precipitate? It's an insoluble substance which is formed in a reaction mixture. Okay, any reaction wherein this precipitate is being formed, that reaction will be named as a precipitation reaction. Now let us consider an example. Na2SO4 plus BaCl2 giving rise to BaSO4 plus 2NaCl. Here there's a white precipitate of BaSO4 that is formed, and it is formed by the reaction between the two ions in the reactants. One is SO4 2 minus and one is Ba2 plus, and the product formed is NaCl, which is formed in the product, it will remain in the solution. Okay, such a reaction in which there is an exchange of ion between the reactants are called the double displacement reaction. So this is what is a double displacement reaction. Here there will be exchange of ions between the reactants. Now Another type of a chemical reaction is oxidation and reduction reactions. Now, when is a substance said to be oxidized, or when is a substance said to be reduced? When is a substance said to be oxidized or it is being reduced? Now, if a substance gains oxygen, it is said to be oxidized, and if a substance loses oxygen during a reaction, it is said to be reduced. Okay, now let us consider an example. Suppose we have an equation CuO plus H2 in the presence of heat getting converted into Cu plus H2O. Here we can say that CuO, as CuO is losing oxygen when it is become like when the reaction takes place, on completion of the reaction, as CuO is losing oxygen, it is said to be reduced. Okay, and it is said to be a reduction reaction taking place when CuO is getting converted into Cu, and when looking onto H2 is getting converted into H2O, that is, it is gaining oxygen, and hence here it is said that oxidation reaction is taking place. Now, taking another example, ZNO plus C getting converted into Zn plus CO. Again here ZNO after the chemical reaction takes place, ZNO is getting converted into Zn, that is, it is losing oxygen, hence the reaction that is taking place here is reduction reaction. And when we look at C getting converted into CO, as C is gaining oxygen, it is known as oxidation reaction that is taking place here. So now we are done with the types of chemical reaction, wherein we learnt about combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and oxidation and reduction. Now we'll be further looking at the effects, certain effects that oxidation creates in our daily life. The two main examples we are going to study about, one is corrosion and another one is rancidity. Okay, now what happens in corrosion? Now, whenever we have observed that whenever an iron article is new, it's very shiny, and but as soon as when it is kept exposed to air for a longer duration of time, there's a reddish brown powdered coating that has been observed on the iron or iron articles. Now, what is the process known as? The process known as rusting of iron. Okay, now some other metals also get tarnished in this manner. There's other metals also which get tarnished along with the iron articles, etc. There's copper, there's silver. Now whenever a metal is attacked by a substance around it, such as moisture, acid, etc., it is said to corrode, and this process is called as corrosion. So whenever there is attack of any kind of acid, any kind of moisture, the metals get corroded. Okay, now the black coating on silver, now we said a brown coating is the rusting of iron. Now we also said there's corrosion or there's tarnishing of other metals as well. Now what is the result of that? Like if it's silver, then there's a black coating that is found on silver, and if it's copper, there's a green coating which is found on the copper metal. Okay, these are the examples of corrosion. Now what does corrosion cause? It causes damage to the car bodies, to the bridges, iron railings, ships, and to all objects made of metals, specifically those of iron. So all the substances wherein the manufacturing has involved the use of metals in it, the corrosion causes damage to all those substances. Now next let us have a look at the next effect of oxidation. It is rancidity. Now rancidity is majorly observed in the food materials which consists of fat and oil. Okay, now there's a change in the taste, there's a change in the smell whenever rancidity occurs in a food material. Why is rancidity caused? So whenever any food, whenever we keep any food containing fat and oil in an open place, the fat and oil which is contained in that food material, it will act with the oxygen present in the environment, it will get oxidized and it will become rancid, and the resultant would be the change in their smell and taste. And to prevent this kind of an oxidation reaction in the food material, usually antioxidants are being added to all those foods which contains fats and oils, so that there's no oxidation taking place and there's no rancidity of the food that is occurring. Now, what measures can we take to prevent rancidity of food materials containing oil and fats is to keep the food materials as much as away from the oxygen which is present in the air, and hence we can make use of airtight containers which will prevent the overexposure of the food materials containing oil and fats to the oxygen present in the environment, and will prevent the oxidation and hence will prevent the rancidity. Thank you.